This is Pre-Calculus, Section 1.5, Day 2 Notes, Part 2. We're still talking about quadratic equations, and whenever we talk about quadratic equations, we always talk about the discriminant. The discriminant of the quadratic equation is the part of the quadratic equation that's under the square root. So the discriminant is the b squared plus negative 4 times a times c. Okay, now it does not include the square root. It's just what's under the square root. And we care about the discriminant because it gives us information about the number of solutions that our equation has as well as the type of solution that it has. So obviously if you're calculating the value of b squared plus negative 4ac, there are three possibilities. The first possibility is that your discriminant comes out to be a positive number under your square root. This tells you that you are going to have two real solutions for your quadratic equation. And graphing wise, if you think about it, hopefully you remember that that means that you're going to have two places where your parabola crosses the x-axis. That's what two real solutions looks like. Now your discriminant could also be exactly 0. And a discriminant of 0 means that you would have one real solution. Visually, that's going to be a parabola that only crosses your x-axis in exactly one spot. Well, the only way that that can happen is if the vertex of your parabola is exactly on the x-axis. And then finally, the third option is that your discriminant could be a negative number. If you have a negative number as your discriminant, then you have a negative value under the square root. And we all know that negative numbers under the square root are imaginary. So this is a situation where we would have two imaginary solutions. Now, graphically, if your parabola doesn't have any real solutions, then that means that it never crosses the x-axis. So maybe it's floating up above or maybe it's floating down below. So now let's use the discriminant to determine the number of real solutions of this equation. We're not going to solve, okay? We're just going to practice working with the discriminant. Our equation is already set equal to 0, so we're ready to identify a, b, and c. Our a is 1, our b is negative 7, and our c is positive 2. Our discriminant, again, is going to be b squared, so negative 7 squared, plus negative 4 times a, which is 1, times c, which is 2. Now we just do the math. Negative 7 quantity squared is a positive 49. Negative 4 times 1 times 2 is negative 8. We add 49 plus negative 8, and we get a discriminant of 41. So what that tells us is that we have two real solutions for this equation. If we were to graph it, our parabola would cross the x-axis in two locations. The last thing we're going to talk about in this section is radical equations. So if you notice this equation here, it has a square root in it. Our first job is going to be to isolate the radical on one side. And it doesn't matter which side, whichever side is more convenient for you. So usually you leave it where it is and you just move everything else out. So as I just said, I'm going to move that x out because I want to get it away from the radical. So now I have the square root of x plus 1 is equal to 3 minus x. Now my next step here in solving is going to be to undo that square root. And of course, you're going to square both sides. That's how you undo something that is square rooted. You square it. And I want to put a little note here because this is really important. The right side will be FOIL. Okay, so make sure that you are foiling and not sprinkling, right? You need to FOIL when you have a quantity squared. So I'm going to square the left side and I'm going to square the right side. On the left side, the square root and the square just cancel, so I just have x plus 1. But on the right side, I really have 3 minus x times another 3 minus x, and I have to FOIL that. So I just continue to work down. When I FOIL first, outer, inner, last, I get 9 minus 3x minus 3x plus x squared. I combine my like terms. So I get 9 minus 6x plus x squared. And now, if I want to solve this, notice that I've got 3 different types of terms, so I need to set it equal to 0. Okay? So when I set it equal to 0, I'm going to subtract my x over, and I'm going to subtract my 1 over. So then I have 0 equals, and I'm going to put my terms in descending order right away as well. So I'm going to have x squared minus 7x plus 8. Okay? So right away you're thinking, oh, I can factor that. But then you try to think of a pair of numbers that multiplies to make a positive 8 and adds to make a negative 7. And it would have to be 2 negatives. But you can't think of a pair that's going to work. Okay? So what this tells us is that we're going to have to use the quadratic formula to solve. So put a little note here. Okay, this can't be factored, so we're going to use our quadratic formula to solve it. A is 1, B is negative 7, and C is positive 8. Okay, so when I plug everything into the quadratic formula, I get x equals the opposite of b. B is negative 7, so positive 7 plus or minus the square root of negative 7 squared plus negative 4 times a, which is 1, times c, which is 8, all over 2 times a, which is 1. And now I simplify. 7 plus or minus the square root of negative 7 squared is positive 49. Negative 4 times 1 times 8 is going to be negative 32. And 2 times 1 is 2. Okay. So then I have x equals 7 plus or minus 49 plus negative 32, that's 17. And the square root of 17 cannot be simplified. Since the square root of 17 can't be simplified, that is going to be what my answer will stay as. So there we go. We're done.